The vast and awe-inspiring Earth may seem monumental, but it is a tiny dot on the vast scale of the universe. Technology has given us the ability to traverse this vast expanse of space, sending rockets and satellites beyond our world to find answers to the mysteries that lie beyond. Our insatiable curiosity drives us further, and each new discovery brings us even more wonder and excitement about the endless mysteries of the universe. But how do we solve these cosmic mysteries? One of the most important ways is through the Voyager missions, which provide us with valuable data to process. But things didn't always go smoothly. For months, there was nothing but radio silence. Then, unexpectedly, Voyager returned, and with it an unexpected and groundbreaking discovery. Join us as we learn about this historic return and what it could mean for the future of humanity. But before we dive into the latest discovery, let's go back to the beginning of the Voyager mission, an odyssey that would forever change our understanding of the universe. Voyager mission. The epic journey begins on August 20th, 1977. Voyager 2 was launched into space, a monumental event that set the stage for humanity's most ambitious exploration of the solar system. Voyager 1 followed just days later. Together, they began searching for exoplanets and sent back data that would astound the world. The early Voyager probes made headlines when they captured unprecedented images of Earth and the Moon side by side in the same frame. But that was just the beginning. The twin spacecraft were designed to do more than simply explore planets. They were designed to explore stars and interstellar space beyond our solar system. Armed with advanced instruments, the Voyagers collected information about magnetic fields, particle densities, radiation levels, and even the composition of interstellar clouds. But what really made the mission groundbreaking was its communications system, which allowed detailed data to be sent back to Earth from the farthest reaches of space. Historic launch date. Many people didn't realize how perfectly timed this mission was. Many people believe that the planets in our solar system move in neat circular paths, but they actually follow irregular ellipses. In August and September 1977, the planets aligned in a way that made Voyager's path as efficient as possible. This was a rare space opportunity. It allowed the spacecraft to continue its journey with minimal adjustments, making the mission possible and a great success. In just over a year, Voyager 1 reached Jupiter and returned more than 4,000 images, including the discovery of 2 previously unknown moons and a new ring around the gas giant. The mission's success was undeniable, and each new piece of data became more exciting. What would they discover next? One of the most breathtaking moments came when Voyager 1 captured a photo of Earth from an incredible distance of 11.7 million kilometers, forever known as the pale blue dot. It was the first time that the Earth and Moon had been seen together from that far away, and it provided an in-depth look at our place in the universe. But that was just the beginning. In 1979, Voyager 1 discovered active volcanism on Jupiter's moon Io, a discovery that shook the planet. But during this period, NASA suddenly lost contact with the probe. It was a busy time for the scientists involved in the project. For months, they worked tirelessly to re-establish communication, and when contact was finally restored, the mission continued with even more groundbreaking discoveries. Perhaps one of the most exciting moments was Voyager 1's flyby of Saturn's largest moon, Titan, on November 11, 1980. The probe revealed details about the moon's dense, nitrogen-rich atmosphere and the possibility of lakes of liquid methane on its surface, suggesting the possibility of life. Titan was no longer a distant, icy moon. It became a fascinating subject for research. Voyager 2 wasn't far behind. By 1986, it had made history by discovering previously unknown rings and moons of Uranus, further expanding our knowledge of the solar system. When Voyager 1 took its famous family portrait of the solar system on February 14, 1990, it was clear that the mission had surpassed all expectations. With unprecedented success, the 2 Voyagers now ventured into interstellar space. Voyager 1 was the first to cross this frontier in 2012, and Voyager 2 followed in 2018. Originally designed to explore the outer planets, the spacecraft has now become humanity's most distant envoy in space. Voyager 1 continues its journey among the stars, 22 billion kilometers from Earth. Although he may be far from home, His discoveries bring us closer to understanding the endless wonders that surround us. In March 2019, scientists studying data from the Voyager 1 spacecraft detected a faint hum in interstellar space. The hum consists of low-frequency radio waves in the range of 3 to 25 megahertz. The waves are thought to be caused by turbulence in the interstellar medium, the region between stars. Turbulence is assumed to be generated by interacting magnetic fields, causing fluctuations in particle density. This buzzing sound has been detected previously by ground-based observatories, but it was only recently that Voyager 1 moved far enough away from the Sun to detect the low-frequency waves. Scientists believe the discovery could help them better understand how galaxies form and evolve over time. Plasma has been part of the Voyager 1 mission from the beginning. The spacecraft observed lightning in Jupiter's atmosphere and studied how the solar wind slows down at the edge of the solar system. Here, the solar wind, the constant stream of charged particles from the Sun, is no longer strong enough to block the interstellar medium, opening up a world of new discoveries. Since then, the plasma around Voyager 1 has been carefully monitored. Voyager 1 is perhaps one of the most important space exploration efforts ever undertaken. It revolutionized our understanding of the solar system and provided the first close-up images of planets, moons, and other celestial bodies. But just a few months ago, it was Voyager 2 that made everyone cringe. Radio silence. In March 2020, NASA dropped a bombshell. Deep Space Station 43, DSS-43, in Australia is the only antenna on Earth that can send commands to Voyager 2. DSS-43 is a critical part of the deep space communication system that allows NASA and other space agencies to communicate with spacecraft. However, it was announced that DSS-43 would undergo major repairs, meaning that Voyager 2 would be unable to communicate for 11 months while it continued its journey into deep space. This decision was made due to several factors, including the station's age, continued use, and environmental damage, all of which made the station unreliable. As a result, the station's hardware and software were updated, including a new antenna that increased its range and sensitivity. Once the repairs were complete, communications between Earth and Voyager 2 were expected to be more accurate and reliable. Scientists are concerned because Voyager 2 is now more than 18.7 billion kilometers, 11.6 billion miles, from Earth and is rapidly moving away from it. Without the ability to send commands and receive data, it would be impossible to study the environment of interstellar space or monitor the spacecraft's performance. The spacecraft still has not been able to receive transmissions, but it has been able to hear its own signals returning to Earth from various instruments and sensors on board. These instruments can collect environmental data, such as radiation levels, temperature, and magnetic fields, and transmit them back to Earth. After months of effort, the reconstruction of DSS-43 is on track to be completed by February 2021. Despite the lack of communication during this time, NASA conducted tests with Voyager 2. In November 2020, mission operators issued a series of critical commands and waited for a response. The tests included sending a wake-up command, turning off certain equipment, and testing the onboard computer memory. Voyager 2 finally responded, confirming that it was in good shape and heading into space. With each message, it continued to send detailed information about interstellar space. Astronomers likened the solar flare detections from Voyager 1 and the information from Voyager 2 to lightning in a thunderstorm, and it was an impressive sight. Scientists once thought that these collisions were the only way to measure plasma density in interstellar space, but the data from Voyager 1 and 2 revealed much more. The whirring noises detected by Voyager 1 allowed scientists to confirm that there is more plasma between solar flares than previously thought. This discovery could prove invaluable to our ongoing space exploration, providing new insights into deep space and its impact on Earth. As we continue to learn more from these pioneering spacecraft, we are left wondering, are there forces at work that we don't yet understand? Voyager's journey continues, uncovering one mystery of the universe at a time. As Voyager continues its journey, it carries with it not only scientific instruments but also messages, humanity's greeting cards. Affixed to each spacecraft are gold plaques containing sounds and images that depict a variety of life and culture on Earth, from greetings in 55 languages to natural sounds like music, thunder, and birdsong. Designed by a committee led by Carl Sagan, these records are humanity's time capsules for any extraterrestrial civilizations that may one day discover the spacecraft. They embody our hope that even as we journey into the unknown, we will extend a helping hand of friendship across the cosmos. But the golden records are as poetic as the Voyager mission is, and the data they are collecting is equally profound. The spacecraft are now passing through the heliopause, the boundary where the solar wind is stopped by interstellar matter. Voyager 1 crossed this threshold in 2012, and Voyager 2 did so in 2018. Going into interstellar space means going beyond the protective bubble of our sun's influence. The space beyond the heliopause is filled with galactic cosmic rays and interstellar plasma. This is where the solar wind is transformed into the winds of distant stars. Studying this environment will help us better understand the nature of the space between stars, where our solar system ends and the rest of our galaxy begins. But even in this unknown realm, the Voyagers are not entirely alone. Both spacecraft continue to detect faint hums of interstellar plasma and occasional shock waves from distant solar eruptions. These disturbances, broadcast from the Sun, eventually reach the Voyagers, giving them a unique opportunity to see how our star interacts with the galaxy.